Okay, here is a video explaining how to find the max and min side of a triangle when we're missing that third side, and it's also going to go into how we set up Pythagorean theorem problems. Now, I'm not going to solve the Pythagorean theorem problems, but I'm going to help set them up. So first, looking at the triangle inequality problem. Remember, when we're trying to find maximums, we need to find our two side lengths that we have, our two given side lengths, and we need to add them together. So 18 plus 13, and that's going to help me find my maximum, because remember, anything bigger, even what that's equal to, it's not going to work, and that's the first time that it's not going to work, and so we say that's the maximum. Because when it's equal to or greater than, we cannot have a triangle. And so we find exactly what it would be equal to by adding them up and say that's my max. For my minimum, I take my two side lengths, 18 and 13, and I subtract them. And I say that's going to help me find my minimum, because in this case, say that we put in what we get, we would equal 5. If we put in 5 here, well, 5 and 13 equal 18, and that's not going to work. And that's the smallest it can get, and then that's the first time it's not going to work. Because you put in 5.1, and you'd have 18.1, and that's big enough to work. And so 5 is that breaking point, because that's when it starts not to work. Okay, so remember, adding for maximum, subtracting for minimum. Now, Pythagorean theorem is always a, and I gotta use my little caret symbol here, if I can find it on my keyboard. I should have looked. A squared plus b, I keep losing my little caret key. Oh, squared equals c squared. And we plug in our a, b, and c value, or whatever ones we're given. Here, I'm given two legs. Okay, so I know these are legs because across from my 90 degrees, there's nothing. And across from the 90 degrees is my hypotenuse, which means the other two are my legs. So if I'm going to set this one up, it's going to be 7 squared plus 2 squared equals c squared. And I work this out algebraically to solve just for c. I don't want to solve for c squared. So remember, at the end, you're going to need to square root both sides. But you go from here and solve it algebraically for just c. Now, on this one, again, it's going to be the same kind of thing. It's going to be a squared plus b squared equals c squared. And this time, though, we have different values, because across from my 90, my hypotenuse is going to be 13.3, which leaves me a leg of 19.7. And so a way you can set this up is a squared plus 9.7 squared equals my hypotenuse squared, which is 13.3 squared. Again, you're going to have to work this out algebraically and figure out what a equals, not what a squared equals. So again, you have to always square root at the end, but you're going to look for what a equals. You're going to look for that missing leg. Okay? Hopefully, if you set it up like this, you're on the right track and you came up with the right a value and then the right c value in the first one.